All right. So I think that it is pretty clear to see that balance is one of the driving universal laws. You know why? Uh, why does entropy work as it does? It's not just because you know, like one. I'm trying to read what my note is here, but the problem is that I did this as like a speech to text thing, and so it didn't translate it like exactly how I said it, and so it just sounds like. And also when I'm talking, like I'll say like a lot, and I'll say and then that just pops up in my thing, and it just kind of is throwing me off. So um, I'm just gonna do a quick read through this. All right, I've got approximation of what I'm going to say in here. So basically, I think that balance is one of the driving fundamental laws, I guess, of the universe. Um, Things lean towards balance. They want to be, um, equal. And, there's a thing out there that says like electrons want like favor the lowest energy state. They want to be at the lowest energy state or whatever. But I don't think that that's true. And I think that it can be seen in entropy, and everything happens in the direction of lower entropy, but lower entropy does not mean necessarily that everything's going to eventually end at zero. No, we're going to end up at this point where the entropy is equal, right? Everywhere, that the heat death of the universe, entropy is equal everywhere in the universe, right? That is what is believed is the direction that our world is heading, and so, or our universe, and so um, uh, every action that takes place is basically heading towards this point of equilibrium, of balance, across the universe. And so, you can say, well, why? I don't think this was necessarily a part of this, but why am I here? Well, you're here to you're here to return balance. You're here to not necessarily in your lifetime, right? But you're here to do your part. Even at the atomic level, everything is basically an entropy increasing machine. Entropy is constantly being increased. No matter what you do, right? That's basically a law that's been established, because anytime you reverse like the entropy of a system, you had to, expend or increase entropy somewhere else, right? So, basically, our lives are the accumulation of every entropy increasing machine that's been devised so far, increasing its complexity, because an increase in complexity increases the amount of entropy that can be, increased. So, if we look down all the way down to the particle level, they're trying to, the quarks are increasing entropy by, taking in energy and expelling it out, basically. And then that makes up the protons are made up by these quarks, and they are using that expelled energy to basically do the same thing but at a larger scale, right? They're taking in more energy because they have more mass, right? And so they do this, and that's why the particles evolved, or atoms evolved from hydrogen into helium and onward into all these heavier elements, and all these heavier elements became a thing because the heavier the element, the more entropy is being increased, because these higher energy or larger mass particles or atoms are creating larger amounts of entropy. They're increasing the entropy by a larger amount. And so they evolved into molecules or whatever, and the molecules are, again, increasing entropy because, by banding together, they're creating a larger mass, and they're pulling in a greater amount of energy and sending out larger amounts of energy and increasing entropy. And we kind of just slowly work our way up, molecules into proteins or whatever, and into these complex structures that eventually become life. And it's not like, oh, boom, all of a sudden life emerged. No, there's two ways to look at it. Everything in the universe is dead and it's not alive. Or everything in the universe is alive. Even the atoms, even the particles, they are alive at a basic level. Because what are they doing? They're taking in energy and they're sending it back out, right? And, if you follow that all the way up the chain, all of these things, what are they doing? They're just taking energy in, they're sending energy out. What are your cells doing? They're taking energy in, they're sending energy out. What are you doing? Well, you wake up, you have some breakfast. What are you doing? Taking energy in. And then you walk around and work and you do your day. What are you doing? Sending energy out. So there is no difference. There is no fundamental difference between your actions as a whole and atoms. Atoms make up you. So it's not. So if you say that, you have to kind of look down the line and you say, okay, well, you're defining something that's alive as something that's breathing and, can think, right? But then you look at trees and it's like, okay, well, we say trees are alive, right? But are they really, they don't breathe like we do, right? They're taking in particles, right? And they're taking in energy from the sun, and then they're, putting energy out in their leaves, in their roots, in their fruits and nuts, and all the sugars that they're building up, right? And so you could argue that, well, they're not thinking, they're not breathing, but we say they're alive. And you kind of just what I don't understand is where you really draw the line with that, because we've established that basically everything, like your body, you look at it with infrared goggles, it glows, right? Because you're emitting infrared light. It doesn't look like I'm glowing, but but everyone is glowing, right? Because we emit infrared light. And you can say, okay, well, why do I emit infrared light? Well, my cells, my body is dissipating heat. Well, what is heat? Heat is energy. where is this coming from? It's coming from my body. It's coming from my bodily functions. Okay, well, what's causing those? Okay, well, maybe my organs, right? Okay, well, what's causing that? Well, cells. Okay, well, the cells, what are they made up of? Well, they're made up of, molecules or, proteins, lipids, whatever. And what are they made up of? Oh, well, they're made up of, atoms and, okay, well then, what are the atoms made up of, right? Oh, well, they're made up of like protons and neutrons and electrons or whatever. What are all those things doing? They're emitting radiation all the way down. Where's that radiation coming from? Well, time for me to go to bed. It's coming from them. They're dissipating energy because they're taking energy in and they're sending it back out. So how is that any different from you? Just because you can think, just because you can talk, you can walk, you can do all these things, it does not change the basic description of what you as a person are doing. If you had to describe any being's behavior in the fewest words possible, I think it's basically take energy in, send energy out. Because that's really what you're doing. It doesn't matter why you're doing it. It doesn't matter when or where. That's what you're doing. And it's all really towards the goal of increasing entropy. It doesn't matter if that's not what you think you're doing. That's what you do by just existing. Even if you do nothing, your body is increasing entropy. So what I'm trying to basically get at here is either we're not alive, right? Because everything that makes us up is dead, it basically is what you're saying. And then all of a sudden life appears because we have consciousness. So you're saying squirrels are dead because they're not conscious, right? You're saying that turtles are just lifeless things. No, they're alive. But you think that they know that they're alive? Do you think that that's on their mind? No, they're just trying to take energy in and send energy out and continue the process. They're continuing to reproduce, to create more of themselves, to create a higher increase in entropy. And so what is the meaning of life? Increase entropy. And we're no different than an atom. We're no different than a proton. So I kind of think that that's something we need to change our perspective on. And I think I really got off of track here of what I was initially talking about. So maybe I'll bring it back home. I'm going to get another alarm going off, so I'm going to turn that off for now. I have a bad habit of staying up late doing things like this. Anyway, what I was really trying to talk about, though, is that there's this balance, right? And the ideal state is balance. The ideal state is this even point. But our entire world is built off of, something and nothing, right? And we're trying to get back to this balance point, right? Where everything is equal. But when everything is equal, all of a sudden, then there's nothing again. Oh, well, if there's nothing, now we have something. Okay. Well, now we want to get back to even. Oh, we're even at 0. Oh, 0, that's nothing. Oh. And we're just basically in this pattern of, cycles. And, you say, okay, well, what is that? If you, watch what I'm doing, basically, it's just a wave function. And we see waves literally everywhere, and cycles everywhere, because it is everything. That's what our world is built on. And that's why that's why we see it everywhere. It's because that's what our world is. And I think that a lot of people look at the world as, atoms aren't they're these particles. We see them as these like particles. They're these unchanging, unaffected particles. They're just there. And they're not just there. They're doing something. There's a reason why atoms exist. There's a reason why everything exists. And it's not defined, and I don't think it's going to be defined by some formula. At the end of the day, I don't think there's a formula to be made here. The truth is that everything exists for a reason, and that reason is because if there's nothing, then that's something. And if there's something, well, we want to get back to nothing, right? We got to balance it back out. But then we're back at nothing again. And, if you want to tie this back, we look at this functionality is everywhere. Like I said, waves and cycles are everywhere. And you look inside of like a proton or a neutron, and we have the quarks in there, right? And these quarks everything has to be balanced, right? We have the two up and the one down, or the one down, or the two down and the one up, right? They balance each other out. And we have the proton and the electron, and they balance each other out. We need to have balance. They need to have equilibrium, because when there's equilibrium, there's stability. And why is there stability there? Because that's the ideal state. Because that's where everything wants to be. Even, balanced. And so we see it everywhere, because that's the building block of everything. And you see in like the quarks, they have the color charge, and there's red, we called it red, blue, and green, right? Well, green is in the middle of, the color spectrum, right? It's balance. And then we have red and blue, which are on the two other sides. And together they make white, which is balanced, because green is already balanced and red and blue cancel out, right? So we end at a net zero. And so we have this constant, they say in the quarks, they're constantly shifting their color charges around, in these gluons or whatever. And the reason they're constantly shifting around is because it's like, you're high, you're low, all right, I'm balanced, all right, well, we gotta, you give some of your energy to that person, and then, I'll give some of my energy to that person, and then, person is in the quarks, right? And then, okay, well, now they're balanced, but now I'm low, right? So, now you got to balance me out. Oh, okay, well, now I'm high and you're balanced, but now they're low, so we got to balance them back out. And so there's this constant interchanging of energy and rebalancing of the equation, basically, to keep them together, to keep them in balance, to keep them equal. And that is the quote-unquote strong force that's going on inside of the proton and the neutron. It's just a balance equation. It's a constant balancing act, and energy is constantly being introduced into the system, and so they constantly have to rebalance, because there's so many factors, shifting the energy. And so that's why the states of these particles are so hard to predict, is because they're being affected by so many things at once that they constantly have to shift to rebalance, to keep themselves stable. And that's why it's so hard to pull like a gluon, a quark out of a proton or a neutron, it's because they fight to keep the balance. They're trying to keep balance, and if they're losing the fight, basically they put so much energy into keeping this balance that they just, when you take it out, oh, there's nothing there. Well, there has to be something, and they just replace it. By if you take that out of the equation, right, then there's nothing there. Okay, well that's the new low point. So then they send energy, and in the form of these like gluons, basically they send these gluons, and these gluons create a new quark through the energy, because you took it out, but it's almost like nothing left, because all it did was just it was just a change in the equation, right? Because if you have one that's high, one that's low, and one's in the middle, well, all of a sudden one's high. Well, they're both high in comparison to this one, but this one's still technically the low point, even though there's nothing there. It just got taken out, but oh no, it didn't get taken out. No, there is a quark there. We just have to. It's almost like a game of denial. They're like, oh no, there is still a quark there. Don't worry, and they just replace it, because nothing really changed in the eyes of the quarks. Their equation is still functional. It's just imbalanced at the moment. They just got to rebalance, and then it's all good. And the same thing could be said for the quark that gets plucked out, because all of a sudden, oh no, this quark is in an imbalanced state. So what does it do? It creates the exact opposite of itself to balance itself. And I think that is fascinating. And that this balancing act is what is basically running our universe. And we see it everywhere. And I feel like calling things positive and negatively charged is a little misleading, because it's taking away from what's really going on there. And it's really more of an attraction and a repulsion. And it should be described as such. Because this positive and negative makes it seem like something else. I don't really know how to explain what I'm saying, but we intuitively know that negative, like what a positive and a negative charge do. But if you told someone that this is positively charged and this is negatively charged, and they didn't know that already, they wouldn't understand what you mean. At least I don't think they would. It's hard for me to know that, because it's hard to know what my understanding would be without my understanding, when I already have the understanding, if that made sense. But I think it should be described as an attractive and a repulsive force, because that is more clear, because that's describing the actual action. Oh, what's a negative force? Oh, well, it's attractive. What's a positive force? Oh, well, it's repulsive. Because if you look at on a magnet, right, the positive end is sending out. Like if you look at the loop, it's going out this way and coming in this way, right? So that's not necessarily easily understood from that term, and I think that is kind of putting a shadow over what's going on there, right? And I don't like it. Because it works. Of course it works, because the description is accurate in the sense that you understand what it means and you define it as such. But I don't think it's the best term, and I think that it's more of an approximation than a true understanding of what's going on there. And us making these terms like, plus 2/3 charge and minus 1/3 charge, like I feel like we're really forcing it there. Like, I don't know. But let's see if anything else was something I wanted to say in that one. Yeah, basically we've got like this duality between something and nothing, and in between there's balance. And like this back and forth is what is basically our world. And yeah. Okay. Yeah, so this is another part that I guess expands it out further. Something, and so that's why I think, yeah, so there was first nothing, nothing made something, having nothing and something created a duality for a balance. In this balance is what has created everything else, because for every something there has to be nothing, and so we're constantly flowing back and forth, creating this balance, so everything is consumed. Then there's nothing, and then after everything gets consumed, it's released back out as something, and so that's why I think black holes are both the end in and the beginning of the universe. And white holes are a theoretically possible but highly unlikely, and so what most likely happens is that we have these big bangs, and these big bangs create everything, but it's quick because it's such an unlikely event, and so it only happens once in the entire existence of the universe, and that is what creates the universe in the first place. And so it's unlikely, but if it didn't happen, the universe wouldn't be here, and so it's actually a certainty. This constant back and forth is what creates the birth and death of the universe in a cycle that repeats in infinity, because we go from points of pure creation into this mix, and then everything settles back out and we're back at balance. But a new universe has been created in the process. New universes have been created in the process to create and continue the cycle. So our universe will eventually die, one day. It'll reach equilibrium. It will be in the ideal state, but in the same time, it created like an uncountable amount of universes to replace it. And so they will continue into infinity, creating more universes. I don't know if that was as clear reading it. I always kind of read it terribly, but I also write it terribly, so that's part of it. But basically, black holes create like a singularity, this point of infinite density. And if mass is energy, right, then a point of infinite density is also a point of infinite energy. And if we have a point of infinite energy, then we are in a prime position for a point of pure creation. So these extremely unlikely events of basically the opposite of a black hole that takes everything in and lets nothing out, a white hole lets everything out and nothing in, it would make sense that when a black hole, forms, basically that point of infinite density is also the spark of a point of infinite energy, and creates basically a new universe. But it's quick and it's fast because it's a highly unlikely event. It's very improbable. So recorded too long. But infinite, this white hole creates infinite energy. It sends it out. It's this fast rush of energy, and we observed it as the Big Bang, and it's such an unlikely event that it only, probably, will only happen once in the entire existence of the universe. But the fact that the universe exists is because it happened, and so even though it's such a crazy unlikely event, it's a certainty that it happened because we exist, right? So, as I've been saying, we look at a black hole as basically, we call it a black hole. It's like there's nothing, right? Everything goes in, but nothing can come out of it. It's just like a hole with no bottom, basically. Pure nothing. But it's also kind of like pure something, right? Because it's got infinite density. And so we get this duality, right? And it just shows that even like on the tiny scale we have duality, and even on the largest scale, the birth and death of our universe, and the propagation of this, right? And it just makes you wonder, like, how long has this been going on for, and could it ever possibly end? Because if we're constantly, like, every time a universe is created, if this is the case, right? Every time a universe is created, it's creating more black holes. And all these black holes are creating universes. And so we have this exponential amount of universes being created. And what's their end goal, right? What is the purpose of them? And the only thing I can say is to increase entropy, but on a scale that we can't even comprehend, or just to continue. Why does anything want to keep living? Because it does. Like, I think that it really comes down to like mainly because we can. So it really just makes you kind of wonder what's going on, and also kind of realize like just how crazy and like small everything is. If you think of things on that scale, we are basically just a proton in the universe. The scales that we could be living on is so crazy. We think we're big. We have no idea. But yeah, something and nothing, and balance, and the cycles that creates, and everything else that follows from it. So, yeah, pretty cool. Peace out.